Yeah, thanks for having me. Thanks for coming. Thanks for staying. I talk about the perfect duo. What I found for myself makes a very good fit. We have Next.js that we love for the UI stuff, and we can also use it for API routes. And there might be a few better solutions to do APIs, and that's where I went with Nest.js because I like TypeScript, so type safety from the front end to the back end. And one big reason that I can talk about already is that you don't have this mental switch between languages. So you talk TypeScript in the front end, in the back end, and you can move front and back. This is quite an advantage, I think. When we develop software nowadays, we talk about domain logics and business services. And when we think about online shops, e-commerce, we have our products, prices, categories, and in our database they live. And then we have our API service and basic CRUD actions, create, read, update, delete. They are fired against our API in form of HTTP requests. We get our data, return JSON, and that's how we build our API. Then a UI comes in place, create React app at some point, then we move to Vite, and we found ourselves happy with Next.js until a new major release and another major release came that made us build things new, from the pages router to the app router, but with all the nice things coming that we will talk about later. So the basic idea is someone goes to a website, sends a request. This request is forwarded to the API service. And again, data is fetched from external services, databases, and returned as a view for the user. So I like to take you on a small journey. When I started developing my own app, it was in 2011 where MVCs, or Model View Controller, it was the architecture, gold standard, state of the art, and still is nowadays in many cases. And then we went to microservices, because everyone does microservices, and we are Amazon, we are Netflix, we do microservices. I don't want to. So I started with a PHP framework, like everyone at that time, doing PHP, especially coming from Java, like a new, fresh breath. And this was my app, Money Garden, a personal finance manager, and I developed it with Flow, the Flow framework. By that time, I don't know if you heard about that. There is Symfony that you might know, Laravel, and this was kind of a niche framework. It was super advanced with dependency injection, aspect-oriented programming and all that stuff. But pretty unstable from release to release. There were major headaches and frustrations. The application grew. It had all that cool stuff built into first with models where your data lives. Then you have the controllers. They take the user requests, and then they fetch the data from the model, inject that model data into the view, and deliver the response to the user in the browser. I developed that for a few years, and the application grew, and I found it quite unpractical at some point, and I wanted to extract some pieces of that software out into microservices at that time. So I developed a service that is connecting with banks, and I get financial transactions from there. And then I developed a categorization service or algorithm that takes these transactions and then classifies this. For example, how much do I pay on insurances, on dining out, on entertainment, on Netflix subscription, on all these kind of stuff. So I wanted a financial picture, and I thought these two services would make sense to have them as microservices. And that's when I started with Nest.js. And it had some of the properties that MVC also had. You had controllers, you had your modules, also like in Angular. So as a backend Java developer or C# developer, you would find right at home with Nest.js, but it's TypeScript. So microservices, great. But then you have to think about authentication. How do users use these APIs? So I needed an authorization, authentication service. There are people on Twitter or X that they say, don't roll your own auth. You might have heard that. You use a service like Auth0 or something in the US, and if you deal with financial data in Germany and you want to fulfill some legal requirements, and then you have your data living on servers in the US, you have some single point of failure, like an attack vector, like difficult. So you want to build it for yourself. It's not so difficult. You should solve passwords. We have NextAuth. We have logins via Gmail, Google, or GitHub. And I thought, I'll do it by myself. Yeah? So why not? So, but at that time, there was no JavaScript library to have an OAuth, single sign-on server. Yeah. I wanted something advanced, OAuth 2, single sign-on, so you log on to one and then you can connect to the other services. By that time, there was only Laravel, really, that had a suitable, easy to integrate OAuth 2 server. And I brought back PHP into my stack, which I didn't want somehow. It had its own database. Classify had its oown database, MariaDB. Connect had PostgreSQL, because why not? Postgres seemed more enterprisey at the time. Everyone goes Postgres, MySQL, the license with Oracle, you should use MariaDB. Okay. But then MariaDB, they used these MySQL commands, and from one day to the other, I updated my containers, didn't start anymore. Why? They changed their MySQL command to MariaDB, and my startup command was MySQL. But they didn't change all their commands, so MySQL dump was still there. Okay, so there was this auth problem. My front-end UI needed to log in against access. I got a JWT, JSON Web Token. With that, I could go to my Classify API, and it turned out like a big headache. And imagine all these dependencies, 3 databases, NPM modules, PHP dependencies, PHP versions. So it became a complete zoo. It was like doing jonglage on a unicycle somehow. And as a solo developer, it's impossible to handle all that. So third iteration, mono repositories. I thought, why not bring Connect, Classify, and Auth under one roof and have one API? So I did that, and I started with Nest.js again. And the cool thing is, even I was a few versions behind the latest Nest.js, I could basically just copy-paste everything because they were organized as modules already. I had my Classify module, Connect module. So I brought everything, and it took me maybe half a day to make it work on the latest Nest.js version. I had TypeORM used already to connect to my zoo of databases and then unified that all to Postgres. And yeah, it was an easy transition, way more than with Flow the other days. There was no flow at all, but with this Nest.js, I was really positively surprised. That also shows a mature architecture that doesn't change much over time. As much as we like new features, great in Next to have it, but you want a robust API, no too many surprises along the way, maybe. So then, right at that time, last year and this year, we got all these great new features, server components. I use them now wherever possible, quick rendering. We go full circle now, back to server rendered stuff. Now and that's also a funny thing that we just discussed with server actions. Oh, they are unprotected server actions. We introduce an ID. By the time in 2011, we had CSRF, if someone knows, yeah, so we had some encrypted value in our form as a hidden value that is sent to the server that could decrypt it. Yes, it's an authorized request because I delivered you the form and now you can give me that data. It's fine. I have the impression somehow we reinvent that right now, but we eventually get there. But the great thing, obviously, is we have server-rendered views, but now we add the interactivity that we love from React. And that was a problem by the time, because iOS apps came along and they gained popularity, and you wanted these smooth transitions between pages, animations, no page reload. So it was really difficult to get that somehow in a way that is nice for the eye. But now with Next.js, it's a totally different game. Yeah, I used Next.auth.js for authentication and session handling. Again, JWT is stored in a cookie used for all API requests. I used Material UI here, but nowadays I would likely go with Schätzchen. Or how do you say that? Schätzchen in German? Schätzchen? But Material is also a great choice, and the LLMs, they know it, so you have great Copilot support, and you can build basic CRUD apps quite easily. So, but why might Next.js not be the best way to build APIs? File-based routing is one thing. If I think about my routes here, they became quite long. /connect, /engines, engine ID, FinTS users, FinTS user ID, accounts, account ID, transactions, update. Maybe it's a design problem, but you know from experience maybe these routes, they can become long. And do you want to navigate that in your file tree? And then all the tabs in VS Code are page, TSX, page, or routes, they are routes then. You can rename that also, but it might not be the greatest for that case. For website structures, it's quite nice. Yeah. Then serverless functions. Great. You have scalability. You don't have to run a Node.js server, but it comes also with trade-offs, especially when you have long-running processes. With Classify, I have some machine learning algorithms, and the trainings, they take minutes or up to an hour. And you mentioned this unstable after. I was thinking, could you delegate it to that maybe, and then give the response quite away? But I think this is something where queue or workers, they come into. So we will talk about that quickly. And the main problem with serverless functions is they have this cold start time. If the functions have been sleeping, there was no traffic, traffic comes on, you have this few 100 milliseconds until it boots up the container, function is run, and then it goes to sleep again. Great to save resources, but for quick responses and instant gratification, these times that we live in, you want snappy behavior, and your API needs to answer in maybe 20 milliseconds instead of 400 or 500. And this constantly. So that is another issue, and we talked about the dev server, transition from pages to app router. If you have many, many routes, the dev server came to crawl and become really slow. That's why we have the new builders. Then hydration, we talked about that already. And the worst, you mentioned it, caching. Who had, sorry, but this idea, I started with the latest Next 14 then. I enter a new category, hit save, redirect to my list, where's my category? And the whole development process, everywhere I went, I call my APIs, where's the data? Clear the cache, what is it? Force, no cache, no store, 0, max, lifetime. So you use all these parameters and throw them around. They changed it now in Next 15, finally. Okay, caching, solved. They listen to the community, great. But the other problems, serverless functions, long-running processes, cold startup times, and the structure in the file browser, how could that be solved? With controllers, we have one single file for my engine here in that case, and you see all the HTTP methods get an engine, delete an engine, post. Here a new engine is trained. I have some API annotations. This is for Swagger or Open API specification. And yeah, then the logic is delegated to the engine service. And you have one file, no hierarchies, flat, and you can easily grasp what are your controller methods. So it's a great overview. You have also a long-running server. That means you can handle longer compute tasks, which take time. But then another issue arises, because JavaScript is single-threaded, and you have a long-running task, and the task is running, and you hit the API, it doesn't react. It doesn't give you any response. So you have to delegate this long-running task to a worker module, for example, to Redis. What you basically do is you copy your whole Nest.js app, but make it a smaller package. It's another Docker container, and the bootstrap process doesn't include all the stuff that I need for my other API. It just has a worker module that knows just enough the engine and the classification it needs to train, and everything else it doesn't see. And then I have an engine training processor, as I call it. It's another TypeScript annotation. So Nest knows this is a processor that deals with workers. You can say how many concurrent workers should be managed by this processor. And every time a user hits the button train engine, I hit my API endpoint. This task is queued in Redis, and now the worker processes go there, take the job, and then the training is performed. And the cool thing is that every worker and the processor, they communicate back their progress. So I can relay that to the UI and say 30% or 300 of 100,000 classifications are processed, so continuous update, and the worker does its job. It's basically a copy of the app, but with a reduced set of logic, and you can use that for long-running tasks. So authentication, authorization, my beloved topic. A user logs in, as we know, on a web front end, and their next auth comes into play. The credentials are forwarded to the API, and we talked about sanitizing input, and also Nest brings some quite nice data transfer object validation pipes. So you can define several validation operators through annotations again, quite elegantly. The token is generated and returned back to the user. It's stored in a cookie, and with every subsequent request to the API, the token is sent. And it's a dual authentication strategy, because if you use the UI and you want to create a new engine, you need to be logged on the platform. Like when you go to OpenAI platform to get or obtain an API token or set your billing details, you have some form of UI. But once you obtain your API token, you can have your third-party application, programmatic access, and then from there you just need to send the API key. So also with annotations, you say on your controller level or on your methods level, this needs JWT authentication, this needs API key, or both are allowed for certain actions. It's also quite nice. Yeah, then the questions. How to build and deploy and deliver that. For Next, you could use Vercel, obviously. It's also possible to host a Next.js app by yourself. Vercel says, maybe don't do it, trust us with it, until you reach certain traffic and so on, then it gets expensive, maybe. And there is absolutely, in my opinion, no reason why you couldn't host it by yourself. There are solutions for everything right now. Image generation, solved. Caching, solved. Maybe some performance, header, edge computing things. Vercel obviously does better, CDN. But for most applications that we have, you can perfectly host a Next.js application by yourself. And the one single term to do that all is Docker. Works all like charm and magic. In case you're not familiar with Docker, you have like a recipe for your app where you say, I need a container, a sandbox to run my app in, and it must be based on some Linux distribution. There are some very thin, slim Linux distros like Alpine, and you select which node version it should run on. 20, I should update maybe. We have now 22, 23 even. You could also have in production or in CI, CD, several configurations and run against different node versions. You can do very cool things with that. And then you take your package.json, you copy it into that container image, and then you run npm install, all packages are installed, you copy your source code over, expose port 3000, and you run npm run dev. Basically the same as if you have it directly running on your machine, but now it's in a Docker container. The same you can do with your Nest.js app. Is a bit different, but quite similar. And the real magic happens in this Docker Compose file. It looks a lot, but you start with your first service here in the top. I have the API. You basically say, where's my build directory? There the Docker file lives. Then you have some environment variables that you hopefully didn't push to GitHub, like we talked before. Then you have some volumes because you want to have your development folder on your machine synced in the container. So it runs always with the latest changes. And also you have hot reloading, everything that we need. You have networks. So all of these containers, you can link them together. The next is the UI. That's where I have the Docker file. You see there's a Docker file development because for local development, I have a very simple Docker file. For production, I use a slimmer image because this image can be 1 gigabyte, 1.5 gigabytes, but I don't need all dev dependencies. Next.js has this standalone output in nextconfig. Standalone output is what you need if you want to deploy it on your own server. And then you need only the build output, very slim node image. This comes on top, and you have like 150 megabytes, very slim images that you can deploy or push to your own registry. I use GitLab, so I have the Docker container registry there, or Docker Hub you could use. And these images are generated in GitLab in my case. I have this GitLab CI file. When I git push my changes, it goes to GitLab, and this CI build runs. It takes the source code, it builds the image, it fires up the containers and does a smoke test. Is there any build errors? From then, let's say build is successful, I push the images, and then I do a simple secure shell login into the virtual private server, my machine. And this can be done from the GitLab CI process. So it's basically a machine logging in into my server. And then it says Docker Compose -f, take the Docker Compose live YAML file because configuration environment variables are different. And then I say pull. And this pulls the latest changes, the latest deltas in the Docker images. And then I do an up-d is a restart, and it should remove the old containers. Okay, now we're live, deployed, short timeout during restart, could happen. Maybe you do some Kubernetes setup to avoid that. Kubernetes, anyone? Yeah? -p? No, this is the project name, like MG platform and so on. So all containers are prefixed with MG platform API, MG platform UI, because I have many containers in different projects, so I need to separate them with a prefix. And it takes the CI project name with this MG platform, and yeah. The ports are defined there in the Docker Compose YAML. No, this is just pull the latest image. Everything has been built already, and then restart. Yeah, it's like git pull npm run dev again, but the Docker Compose way. So if you're not going the Kubernetes, AWS, Google Cloud way, and you start simple and you want to try out to use your own servers, I can highly recommend Hetzner Cloud. I had always my own managed bare metal servers, but recently I started using Hetzner Cloud. You get €5, €8 servers. It's pretty amazing. And then you have it preloaded with Docker, so you don't even need to install that. And Coolify is another really cool thing that you should check out. This is new. This has been introduced 2 weeks ago or so. And you have Vercel on your own VPS. Oh, not. You have a catalog of hundreds of open source tools, apps, NoCoDB, N8N, a workflow engine processor. Pretty amazing. So you just install, click, app. It gets the SSL certificate, and you have the software running on your own server. It got really, really cool. And the stage before would be you use Docker, you get your source code or your images in the Docker registry, you connect your VPS, and to pull these images, and now I have these 2 running containers, plus the database and maybe Redis. And then you can activate a firewall because you only want to expose HTTP port, SSL, and SSH, because sometimes you want to do an Ubuntu update or install some package that you might need, Python maybe. Okay. If you want to go more advanced, you could also add a load balancer. I think they cost a few euros. And then you can also add more hosts, more containers. You can also load balance your API containers. And if you have a real production environment, you would most probably have a database cluster with primary, secondary nodes, and maybe also Redis. But some people do queues also in Postgres. You can use Postgres nowadays for almost everything. I like it for caching and queuing. So what are the advantages of this architecture? For me, the most part, as I said, as a solo dev, I keep the same mental model. I have the same language that I talk, and it's not the same that you have PHP, Python, or Java on the server, complete different package management, build process, and then you switch back to the front end. You have different data transfer objects. So you can basically use the same DTOs. It's like a contract that you have between front end and back end. And if you change something in your code or in DTO, you will immediately see inconsistencies across your app. Yeah? And this is the big benefit also that I see. You have TypeScript that we hopefully all love and like, except DHH, David Heinemeier Hansson, you know him. Completely switched from TypeScript to JavaScript. We love dynamic languages, Ruby, duck typing, and so. Yeah, fair enough. So, sharing of types, we talked about these. And yeah, where do we go from here? What else can we build with that? So as I said, if you want to develop further, now you're a full stack developer, you want to reach into machine learning maybe a bit. I do this also with JavaScript, with Natural.js. You can do many machine learning tasks with that already. You can use Vercel AI SDK, for example. You could think the AI SDK is for Next.js or Vercel, but I used it in Nest. There where I do my machine learning stuff, I use the AI SDK so I can connect with OpenAI or Anthropic for Claude, because I use this for classifications also. And you can build that also easily there. You have streaming support, WebSockets, you have this type ORM mapping, you have your routes secured. You can add rate limiting to your Nest.js routes. So I don't know how to do that with server actions, but in Nest it is just an annotation, another TypeScript annotation where you say rate limit these functions, or on controller level or on module level. So yeah, what are you going to build with that? I'd be interested to see. And what do you think? Do you agree, disagree? Yeah, and that's Connect. I'm on LinkedIn, the bespoken social media where I found to this meetup. Seems to work. Okay.
It does.
Thank you.
Thank you, Thomas. Awesome talk.